Alright, so in this video we're going to be doing some mathematical operations with counting six figures. And so just make sure that before you watch this video that you understand how to assign the appropriate amount of six figures for a particular number, because you're going to be needing that for this video. Alright, so let's get started. So the question is saying calculate each of the following operations and provide the appropriate amount of significant figures. Alright, let me just zoom in a little bit. Okay. So, as you take chemistry, you're going to find that you're going to be doing a lot of mathematical calculations, alright? And every single answer you put on an exam or a homework or wherever it may be is going to have a certain is going to require a certain amounts of significant figures, right? And the amount of significant figures that you have to provide is dependent on the mathematical operation you're doing, whether it's multiplication and division or addition and subtraction, right? So, for example, in multiplication, which is what we have here to begin with, you always take your answer should have the same amount of significant figures as the value inside the question with the least amount, if that makes sense. So, for example, right here we have 3.02 and 25. So, based on the other video, you should ascertain that there's 3 significant figures in this number and 2 significant figures in 25, right? So our answer should have 2 significant figures. Alright, so you would plug 3.02 times 25 into your calculator like always, and you would find that the answer to that is 75.5. Okay, so how do you convert that into significant figures? Well, you have to round up because you have to have 2 significant figures and not the 3 significant figures that 75.5 has. So your answer should be, so it's first 75.5, which has 3 significant figures, which should round up to 76. And that's the answer you would put on an exam or a homework question. Alright, the next example here. So we have 7.00000 times 54.0. Alright, so in the 7.00000 we have 6 significant figures, right? 6 right here and 3 over here. Now, ask yourself, how many significant figures should your answer have? And the answer to that question should be 3. Okay, so when you put that calculation into your calculator, you get 378. Now, you needed 3 significant figures, and that answer has 3 significant figures, so you don't have to do any rounding. You just leave it as 378, and that's perfectly fine. So the next calculation, we have 23 and 8.2. Each of those have 2 significant figures, so our answer should have 2 significant figures as well. So 23 times 8.2 equals 188.6. You have to round that up to 2 significant figures, and this is where you would need scientific notation, right? So even if you were to put 190 with a decimal point right there, that would have 3 significant figures, so you have to it's not going to be good enough. So you're going to have to use scientific notation to express this answer. So you're going to move the decimal over twice to the left, meaning that your answer should be 1.9 times 10 to the 2. And that would be the correct answer for an exam or a homework question. Alright, so now let's move on to division over here. So division, although it's a completely different mathematical operation, it's going to follow the same rules as multiplication. We're going to use the least amount of significant figures that one of our values has. Okay, so right here in 1.739 we have 4 significant figures. In 0.021, recall that these two zeros to the left of the first non-zero digit are insignificant. So our answer is only going to have 2 significant figures, or that value is only going to have 2 significant figures. Therefore, our answer should also have 2 significant figures. All right. So if you were to plug in 1.739 divided by 0.021 into your calculator, you'll find that you'll get 82.8095, right? That's a really big number, and we're supposed to put that into 2 significant figures. So it's approximately 82.8, and we're going to round that up to 83, and that's the answer we would put on our exam. Okay. So the next one, 90.06. these two zeros are significant because they're in between these two non-zero digits. So this value has 4 significant figures. Now, inside the 0.730, this 0 is significant because it's to the right of this first non-zero digit. So this value right here has 3 significant figures. So, therefore, our answer should have 3 significant figures as well. Okay? So if you were to plug in 90.06 into your calculator divided by 0.73, the answer should be 123.36986. Alright? So it's about 123.4, and we have to get that into 3 significant figures. So what we're going to do is we're going to round that down just to 123. Right? And that gives us our 3 significant figures that we require, and that answer choice is good like that. So hopefully you understand multiplication and division so far. It's pretty straightforward. Just take the least amount of significant figures that the question may provide you. Alright, so let's look at addition and subtraction here. So addition and subtraction, it's very simple as well. Let's go ahead and change colors. So 13.02, and we're going to be adding that to 1.009. Now in addition and subtraction, we always go to the least amount of decimal places after the decimal that one of our answer choices has. For example, 13.02 goes 2 places after the decimal. It doesn't have anything in the hundredths place over here. So what we're going to do is we're going to completely forget about this 9 over here, and we're just going to add the 2 to the 0 to make 2 0.41. So 14.02 is our final answer for this one. Alright, notice we didn't put an imaginary 0 here and bring down the 9. With addition and subtraction, you just go with the least amount of decimal places after the decimal. Okay, now let's look at the next operation. 48.0, and I'll write it a little bit off to the side just so we don't get mixed up, plus 9.0872. Okay, now these are a lot of numbers after the decimal point, but we're going to forget about these because they're not because our 48.0 has nothing from the tenths place on. Alright, so we're going to go bring down the 0 points, and then this makes 17, so it's going to be 57.0, and that's our final answer for this operation right here. I'm just going to draw an arrow right here indicating that's where we went. Alright, let me draw another color. So this mathematical operation over here is getting a little bit messy. 43.012 plus 6.988. Alright, so in this case our values line up perfectly after the decimal point. They each go up to the thousandths place. Alright, so this is 0, carry the 1 over here, 0, carry the 1, 0, carry the 1, 0, carry the 1, and we have perfectly 50.000. Alright, now let's do the next one. 2,548 plus 125.0 and 9.303. Alright, now this 2,548 is going to set the tone, and since it has nothing at the 10th place, we're going to completely forget about all decimal points here. Alright, so we're just going to worry about this 5 plus 8, which is 13, plus 9 makes 22, so we carry the 2 over here. 2 plus 4 is 6, plus 2 is 8, 1 plus 5 is 6, and 2. So 2,682. Now let me go ahead and do another color for this. So this is going to go over here. So let me go ahead and scroll down a little bit. 8.450 plus 12.38 plus 7.0012. Alright, Now, if you may have guessed, we're only going to consider the tenths and hundredths place, for there's nothing in the thousands place in this 12.38 number. So let's go ahead and forget about this, and forget about the 0. So 5 plus 8 is 13. Carry the 1, makes 8. So 7 plus 2 is 9, plus 8 makes 17, which makes 27.83. Alright? Now over here, let's go and do the final operation in red. 42.01 plus 37.0. So we're going to forget about this 1 in the hundredths place, and we're just going to carry down the 0. So this makes 79.0. Now, if you noticed, in addition and subtraction, we do not care about significant figures to the left of a decimal. So all of the numbers that are greater than 1 are greater than or equal to 1 are going to add just like you normally add them. All right. The only thing we care about is the values to the right of the decimal. So we always go with the least amount. So for example, we went with 2 here. We went with 3 here since they both had 3. Over here we went with nothing. Right? So hopefully that made sense to you. If you have any other questions, go ahead and ask your peer leader. Thanks for watching, and I hope you enjoyed.